Hello everybody. In this lesson, we will study about the pair of linear equations in two variables. We have already studied linear equation in one variable, and we have also studied the general form of a linear equation in one variable. Example, ax plus b equal to 0. We can give some values of a and b. 2x plus 3 equal to 0. So this is an example of a linear equation in one variable. Let us take the general form of a linear equation in two variables. It's going to look something like this: ax plus by plus c equal to 0. If you have to take an example, 2x plus 3y minus 5 equal to 0, where a is 2, b is 3, and c is negative 5. We can write this equation as 2x plus 3y equal to 5 when we move the minus 5 on the other side. So this is an example of a linear equation in two variables. We also know that a solution of a linear equation in two variables will have a pair of values, one for x and the other for y. What do we mean by a solution of the equation? The solution of the equation is those values of x and y where the left-hand side of the equation will be equal to the right-hand side of the equation. We say that the x and y have the solutions for this equation. For example, let's take the value of x to be 1 and the value of y to be 1, and we plug it into the equation. So what happens? 2 times 1 plus 3 times 1 equal to 5. 2 plus 3 equal to 5. 5 is equal to 5. So we see that the left hand side is equal to the right hand side. So we say that 1, 1 is the solution of this equation. Now in a second case, let's take the value of x to be 1 and y to be equal to 7 and see what happens. 2 times 1 plus 3 times 7 equal to 5. So this is going to be 2 plus 7 times 3, 21 equal to 5, and 21 plus 2, 23 not equal to 5. So we know that here left hand side is not equal to the right hand side. So the pair 1, 7 is not a solution of this equation. What does it mean graphically? It means that when we say 1, 1 is a solution of this equation, it means the point 1, 1 lies on the line representing this equation. And when we say 1, 7 is not the solution of the equation, it means that 1, 7 will not lie on the line representing this equation. So geometrically, a solution of the equation will lie on the line, will be a point on the line of the equation. And a point not on the line of the equation is not a solution of the linear equation. And we know that the graph of a linear equation is always a straight line. When do we say that two linear equations are said to be a pair of linear equations? When the variables in the two linear equations are talking about the same information, when they are representing the same information, we say that the two linear equations are said to be a pair of linear equations. And the general form of a pair of linear equations will be a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2, c2 are all real numbers, and a1, b1 together cannot be equal to 0, and a2 and b2 together cannot be equal to 0. Both together cannot be equal to 0. So when the variables in both the equations are representing the same information, they become a pair of linear equations. We can have examples over here. For example, 2x plus 3y minus 7 equal to 0, 9x minus 2y plus 8 equal to 0. This can be said to be a pair of linear equations. We can take another example. 5x equal to y. This is one linear equation. And negative 7x plus 2y plus 3 equal to 0 can be another pair of linear equations. So now we know what a pair of linear equations in two variables mean, and we also know the general form. So when we have a pair of linear equations, and when we graph this pair of linear equations, we will have two straight lines, one for each linear equation. And when we have two straight lines in a plane, there can be only one of the three possibilities. So in one possibility is the two straight lines could intersect each other at one point. Or the second case could be where the two straight lines never intersect. They are parallel. Or the third case could be that the two straight lines overlap each other, coincide with each other. So it can be only one of these three cases. Either they intersect at one point, or they never intersect at all, in which case they are parallel, or they will coincide over each other. Now when they intersect at one point, the linear pair will have only one solution. In the second case, when the lines are parallel, the linear pair will have no solution. And in the third case, when they coincide, it will have many solutions or infinite number of solutions. So these are the only three cases, one of which will be true when we graph any pair of linear equations. We will look at some of the examples of how we graph a linear pair of equations and see how we come to the conclusion of finding the solutions. Let us graph this pair of linear equation. We can write y equal to half x in a more simplified way by cross multiplying, get 2y equal to x. We can move this over here, so x minus 2y equal to 0. This is another form of writing y equal to half x. Now what we can do is, in order to graph, we need to have some points, some coordinate points. And we know how to graph a linear equation by choosing some values of x, finding the corresponding values of y. So we will choose some values of x and find the corresponding values of y and write it in the form of a table. This is the table we get when we plot when we choose x as 0 and y as 2 for our equation y equal to x over 2. Now we will plot the table for our second equation 3x plus 4y equal to 20 and see what we get. So our second equation is 3x plus 4y equal to 20. In order to simplify, we can do this. 4y equal to 20 minus 3x. And dividing by 4, we get y equal to 20 minus 3x over 4. It's the same equation represented in this way. Now we can choose the values of x and find the corresponding values of y and write it in the form of a table and see what we get. So when we plot the values of x as 0, 20 over 3 and 4, we get the values of y as 5, 0 and 2. So now we have the tables for both the equations and we can plot the graph for both these values, both these equations. When we plot the points for each equation, this is the graph of our first equation and this is the graph of our second equation, and we plot both the graphs. Both these lines intersect at one point, the coordinates of which are 4, 2. So since they are intersecting at one point, we say that the solution of this equation is 4, 2. So we can now know graphically how to find the solution of a linear pair of equations in two variables. We know that a pair of linear equations will have one solution when their lines intersect at a single point. So we have only one solution for this kind of a linear equation. We can determine this by looking at the graph. But can we determine by algebraically how many solutions does a pair of linear equations have? Yes. When a1 over a2 is not equal to b1 over b2, then the lines will intersect at only one point and it will have exactly one solution. So algebraically we can know when a pair of linear equations will have one solution. Graphically we know when a pair of linear equations will have only one solution. Whenever there is only one solution, it is called a consistent equation. It is called a consistent pair of equations. Now, when does a pair of linear equations have no solutions? We have seen the second case when the lines are parallel to each other. That means when they do not intersect. This is graphically. But can we know algebraically when the equations will not have a solution? When a1 over a2 is equal to b1 over b2 and this is not equal to c1 over c2, then the pair of linear equations will have no solution. And when there is no solution, we say that the linear equations have an inconsistent pair of equations. And the third case is when both the lines overlap. So when we have the two lines of the equation overlapping, we say it has infinitely many solutions. This is graphically. Algebraically, it will be when a1 over a2 is equal to b1 over b2 is equal to c1 over c2, then the two lines will overlap and it will have infinitely many solutions. and we say that the linear pair is a dependent pair of equations. So the three cases can be determined either algebraically or graphically. Let's take some examples and check our results. Let's look at this example. We have a pair of linear equations, x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. Let's first figure out what's a1, b1, c1, a2, b2, c2. So a1 over here is 1, b1 is negative 2, c1 is 0, and over here a2 is 3, b2 is 4, and c2 is negative 20. Can we determine what is a1 over a2 over here? It is 1 over 3. What is b1 over b2 over here? It is negative 2 over 4, which is negative 1 over 2. And what is c1 over c2? It's going to be 0 over negative 20, which is 0. Do you observe that a1 over a2 is not equal to b1 over b2? So how many solutions will this pair of linear equations have? It will have only one solution. It will have only one solution. That means the lines will intersect at only one point. So it is a consistent pair of linear equation. Let's look at this example. This pair of linear equations, 2x plus 3y minus 9 equal to 0, 4x plus 6y minus 18 equal to 0. So let's figure out what's a1 over a2. a1 is 2, a2 is 4. If you simplify, it's going to be 1 over 2. What is b1 over b2? b1 is 3, b2 is 6. Simplify, 1 over 2. What is c1 over c2? c1 is negative 9, c2 is negative 18. Simplify, it's 1 over 2. Do you observe over here, a1 over a2 is equal to b1 over b2 equal to c1 over c2. So can you guess how many solutions will this pair of linear equations have? Right, it will have infinitely many solutions. So this is a dependent pair of equations. When we graph them, these two lines will overlap on each other. Such lines are also called as coincident lines. Okay, let's look at this. X plus 2y minus 4 equal to 0. 2x plus 4y minus 12 equal to 0. How many solutions will this pair of linear equations have? So let's figure out what's a1 over a2. a1 is 1, a2 is 2. What's b1 over b2? b1 is 2, b2 is 4. If we simplify this, it's 1 over 2. What's c1 over c2? c1 is negative 4, c2 is negative 12. Simplify, it's going to be 1 over 3. What do you observe? We observe that a1 over a2 is equal to b1 over b2, but they are not equal to c1 over c2. So what does that mean? It means that the lines are parallel lines and it has no solution. When the lines are parallel, they are called inconsistent pair of equations. Let's look at this word problem and try to solve this equation. Romila went to a stationery shop and purchased 2 pencils and 3 erasers for rupees 9. Her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of the same kind for rupees 18. Represent the situation algebraically and graphically. The real challenge in such type of problems is to represent the problem in the form of a linear pair of equations. Once we get the linear pair, then graphing becomes easy and solving the equation and finding the number of solutions gets easy. So let us figure out how to represent this equation in the form of a linear pair. To begin with, let the cost of one pencil be X rupees and the cost of one eraser be Y rupees. Then 2 pencils and 3 erasers cost 9 rupees. This is the first case of the problem. So we can write it as 2x plus 3y equal to 9. And the second case is 4 pencils and 6 erasers cost 18 rupees. So we can write it as 4x plus 6y equal to 18. So we have represented this problem in the form of a linear pair of equations. Now it gets pretty easy to solve it graphically and algebraically. So we can choose random values of x and find the corresponding values of y for each equation respectively. For the first equation, our x and y will be 0, 3, 4.5 and 0. And for the second equation, when x is 0, y is going to be 3. When x is 3, y is going to be 1. Now we can plot these two lines and see what happens. When we graph these two equations, we get this line. And do you observe that both the lines are overlapping? So this has infinitely many solutions. So we have represented the problem algebraically and we have solved it graphically. Let's try this. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Also, 3 years from now, I shall be 3 times as old as you will be. Is not this interesting? Represent this situation algebraically and graphically. So I will be representing this algebraically and I leave it upon you to represent it graphically. Because the real challenge of all such problems is to represent the equation as a linear pair of equations. And from then on, we have already learned in our lower grades how to graph linear equations. So that becomes pretty easy. So let's go ahead. Let Aftab's present age be X years and daughter's present age be Y years. So now, coming to the problem, 7 years ago means Aftab's age 7 years ago will be X minus 7. And the daughter's age 7 years ago will be Y minus 7. The problem says 7 years ago I was 7 times as old as you were then. So we can represent this as Aftab's age 7 years ago is equal to 7 times the age of his daughter. So this will be the first part of our equation. We can simplify this. X minus 7 equal to, open the brackets, 7y minus 49. We will bring x and y on one side of the equation. X, when 7y comes on this side, it becomes minus 7y equal to minus 49. When this negative 7 goes there, plus 7. So x minus 7y is going to be equal to minus 42. Or we can write the same equation as x minus 7 plus 42 equal to 0. We can represent this whole equation as 1. Now the second part of the problem, 3 years from now. So if Aftab's age is x now, 3 years later it will be x plus 3 and his daughter's age will be y plus 3. I shall be 3 times as old as you will be. So let's see how we represent this part of the equation. So Aftab's age 3 years from now is going to be x plus 3. His daughter's age 3 years from now will be y plus 3. And the problem says Aftab's age will be 3 times that of his daughter's age. So this is the second part of our equation. We can simplify it. X plus 3 equal to 3 times y is 3y plus 3 times 3 is 9. Let's move all the variables and the constants on one side of the equation. So x, 3y when it comes here, minus 3y plus 3 minus 9 equal to 0. X minus 3y minus 6 equal to 0. This will be the second part of the equation. Of course, it's going to be the same one. It's only simplified in a different way. So we have two linear equations now, which form a pair of linear equations. And we can graph this pair of linear equations as we have learned in our lower grades and see what the solutions are. Let's try this. The coach of a cricket team buys 3 bats and 6 balls for rupees 3,900. Later, she buys another bat and 2 more balls of the same kind for 1,300 rupees. Represent this situation algebraically and geometrically. We will represent it algebraically and I leave it upon you to represent it geometrically. Let the cost of a bat be x rupees and the cost of a ball be y rupees. So 3 bats will cost now 3x and 6 balls will cost 6y. And together their cost is 3,900. So this can be written as 3x plus 6y is equal to 3,900 rupees. Now the second part of the problem, she buys another bat, means 1 bat, and 2 more balls for the same kind for 1,300 rupees. So 1 bat and 2 more balls, so 2y. The cost of those two is 1,300 rupees. So we have two linear equations over here which can be represented graphically. The cost of 2 kgs of apples and 1 kg of grapes on a day was found to be 160 rupees. After a month, the cost of 4 kg of apples and 2 kg of grapes is 300 rupees. Represent the situation algebraically and geometrically. So let the cost of 1 kg of apples be x rupees and the cost of 1 kg of grapes be y rupees. So according to the first part of the problem, 2 kgs of apples will be 2x rupees and 1 kg of grapes will be 1y. And they both together, the cost is 160 rupees. So that's going to be the first part of an equation. In the second case, the cost of 4 kgs of apples, so it's going to be 4x, and 2 kg of grapes is going to be 2y, and the cost of that is 300 rupees. So this is the second part of our linear equation and we can graph them together. Champa went to a sale to purchase some pants and skirts. When her friends asked her how many of each she had bought, she answered, "The number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased." Help her friends to find how many pants and skirts Champa bought. So let the number of pants be X and the number of skirts be Y. So in the first part of the problem, the number of skirts is 2 less than twice the number of pants. So let's see this. So the number of skirts Y is 2 less than twice the number of pants. Twice the number of pants and 2 less than that. So that is going to be the first part of our linear equation. In the second part of the linear equation, she says the number of skirts is 4 less than 4 times the number of pants purchased. So the skirts in the second case is 4 less than 4 times the number of pants. So 4x minus 4. So this is going to be the second part of our linear equation. And we can graph these two equations. Let's try this. Half the perimeter of a rectangular garden whose length is 4 meters more than its width is 36 meters. Find the dimension of the garden. So we know that a rectangular garden, let's take the shape of the rectangular garden to be something like this. And the length of the garden, and this is the width of the garden. The question says the length of the garden is 4 more than its width. So the length is 4w plus 4. And we know that the perimeter of the garden is 2 times length plus width. And the question says half the perimeter of the garden is 36 meters. So half of P is 2 times length plus width is equal to 36. We cancel off the 2. So length plus width is 36. This is one equation. Can I write this as L minus W equal to 4? Just rearranging the terms. So I have the second equation as L minus W equal to 4. And now they form a pair of linear equations which can be graphed and found the dimensions. To summarize, we learned that two linear equations can be represented as a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. And the second part we learned is that the equations can be represented and solved by graphical method and by algebraic method. And in the graphical method we learned that if two lines intersect at a point, we say that the solution is consistent. And if the two lines overlap each other, we say that the solutions are dependent. And if the lines are parallel, we say that the solution is inconsistent. So this was all about the pair of linear equations in two variables. Still, we need to know about substitution and elimination methods, which will be followed up in the coming videos. Thank you. You're doing a great job taking the initiative of learning mathematics, and I really appreciate that. I hope you will share and subscribe to this video. Thank you.